Hello, good evening. Hope you all are having a wonderful weekend. And let's talk about something interesting in this weekend. Uh, this is about artificial intelligence, data science, and machine learning. These subjects are becoming hot topics these days, and everyone is talking on these
Hello, good evening.
buzzwords. So that's
Hope you
why
all
we hope to
are
talk
having.
about these subjects. And this is like so. First, to get start, we'll get a look on this awesome video. This was a video I took from Text Insider. That small tiny thing, we'll call it a man, was not working according to a program that is well structuredly written, a normal program that you have seen in your day-to-day life. It is totally based on artificial intelligence, and though it seems a bit goofy and simple, that is like one of the major creations that they have invented right now with Google DeepMind. So we'll move forward with these subjects: artificial intelligence, machine learning, and data science. So if you have any questions regarding these fields and the things that I am going to discuss, just comment below and we'll try to answer for those questions. So I'm Haritha Thilakarathne. I'm working as an engineer for data science and analytics at Tech1 Global. And also I'm a Microsoft MVP in the field of artificial intelligence. Also I'm attached for Stanford HCI Group Cloud Research. You can find me through this URL. So why this artificial intelligence has become this much like with it a good hype these days? Have you ever heard of Industrial Revolution? So in the first Industrial Revolution, we were like talking about water power and the steam power, steam engines and all. And then the second Industrial Revolution came. It was all about mass production and assembly lines, having production lines, and electricity was the greatest invention that we had in second Industrial Revolution. Then we moved for the third one with computers and automation. Robotic arms and those things came on the third industrial revolution. After that, in this era, we are talking about the fourth industrial revolution that attach with cyber physical systems. Cyber physical systems is all about sense networks and intelligent real-time processing with embedded software for logic, big data provisioning, and advanced robotics. This was a bit deviated from what we had back in third industrial revolution. In the third one, we had automation with computers, but not so much involved with data, not so much involved with the data and the insights that we get from the data. When it comes to the fourth industrial revolution, we are talking a lot about data and what we going to do with these data. So this is a simple chart I got from Google. This says like how the people interested in these fields. These three letters, AI stands for artificial intelligence, while ML stands for machine learning, and DL stands for deep learning. I'm going to talk about deep learning a bit. So you can see in 2012, back in 2012, there's not much of hype on those subjects, but you can see when it comes to 2015 and 16, this is getting a gradual, like exponential hype uh, about the interest. That means people are so much interested and searching a lot on these subjects. So you might be confused. What are these fields? Like people talk about AI, ML, pattern recognition, and data mining. Are these fields are all involved or all like deviated? Th- What are the differences and those things? So I would say all these subjects like AI, machine learning, pattern recognition, also neurocomputing, KDD, data mining, all are like tangled and all are like bit connected, all have interconnection between them and all are serving one one each other. We'll talk on each of these fields in couple of like minutes. AI. So this meant to be a cool field, and I'm pretty sure you are familiar with this guy. Are you familiar with this guy? Right. This is Sir Alan Turing, born in 1912, and tragic. He had to be in a tragic death in 1954. I would say he is the one who defined what is artificial intelligence in the first. Can you remember this film, this nice lady? Uh, this is a robot who was in the film Ex Machina. So, what I'm going to tell was Alan Turing described what artificial intelligence is with this supercode. He said a computer would deserve to be called intelligent if it could deceive a human into believing that it was human. That means we'll say, all Turing test, right? If you don't know, just Google and see what is Turing test. So he said, if a man can deviate whether there's a computer in a room or whether there's a man in a room without seeing, and if the computer can, like intimate as a human, that meant to be an artificial intelligence. That was Alan Turing's definition on artificial intelligence. So things that you see in future would come close to this definition that Alan Turing gave. That means the capability of a machine to imitate intelligent human behavior. That is what Webster is saying about artificial intelligence. And people talking about artificial intelligence a lot because there are many interventions that you can see currently that comes with artificial intelligence. Can you recognize this one? Yes, I know. This is Tesla, the well-known Elon Musk's electric car, and that is having the capability of self-driving. This is some kind of an big achievement that artificial intelligence has got so far. This car is processing images as well as the videos to drive through the highways or the freeways uh, with artificial intelligence. And can you recognize this tiny one here? Yes, that is Google Home. This is a Google Assistant that you can buy right now from Google. And also, Microsoft is providing something like this with Harman Kardon, as well as Alexa from Amazon. Those are some cool gadgets like this. Having bit artificial intelligence inside these equipments that can help you with your little home household activities like playing a music, or doing some playing some video and getting a recipe from the internet. Those things can be done with these instruments. And this one, Dota. Have you played Dota? I know. So if you watched the Dota 2 series that recently had in US, a machine, artificial intelligence, will say an artificial intelligence algorithm that was created by Elon Musk, uh, got the chance to beat the world Dota champion. So it was an amazing achievement that artificial intelligence has got through to beat a real world champion in an online game. And this beast creature, I know this is from Boston Dynamics, though it looks bit glossy and bit look with fear, but it's also an achievement of artificial intelligence. This creature, that having four legs, is capable of walking through any harsh environments and in a rough terrain, with no idea what he's getting in the future, by learning the things that he see in the environment he's learning, actively learning. And this is a huge achievement that artificial intelligence has got so far. So that is some kind of cool stuffs that you can see currently in the world that artificial intelligence has got through. For all those things, many algorithms, basically mathematical algorithms, has played a great role behind all these magics. And then the machine learning part. Machine learning is not a new term. I would say it's not a new term because it came to the world far, far back, but it got the hype because of some external resources and external factors that came into the industry. Bill Gates, a well known guy, he said a breakthrough in machine learning would be worth 10 Microsofts. You know, like how much Microsoft is worth. The founder of Microsoft, Bill Gates, said the thing he created would worth like 10 times if there's a breakthrough in machine learning. That means machine learning is that much of important. Why it is that much of important? What is the feature that make machine learning that much unique? I'm pretty sure you're familiar with this map because this is the roads that we getting normally in a busy weekday in Colombo, Sri Lanka. So all these magic, that means where the traffic is, where we can find out a simple way or easy way for home or easy way to work. You can find out from the Google Maps very easily how the Google is doing this magic, how they are mapping the real-time traffic. They are doing this magic using the sensors that you have in your Android phone or the iOS phone. Google is capturing all the data from the phone, and he's mapping these things into your machine, or your map, with machine learning algorithms. Those are some cool stuff going through big data, data analysis, and data visualization. All these parts have done using machine learning. So actually, what is machine learning? I would say machine learning is a scientific discipline that makes that algorithms that can learn without human intervention. Uh, I'm emphasizing fact that like algorithms that can learn, those are the algorithms, they have the ability to learn by themselves without human interventions. So like such algorithms operate by building a model like based on inputs mean the input data, and using that to make predictions or decisions, right? Like how we did programming before. Take a look. So Previously, what we did was we had some procedural instructions. We'll say if else or switch cases, if else ladders or functions, those kind of stuff guided the program where to go and what to do. That was done totally by a human. But in this case, in machine learning, we have algorithms that can learn without human interventions. That is the main difference between normal programming and machine learning, right? Okay, we'll move forward, and this is a small meme. It says, like, if you search for some cool stuff in eBay, you'll definitely get an advertisement about that on your Facebook right on the spot. I'm pretty sure you have experienced that thing. So, machine learning has involved in this thing, making recommendations for you. eBay is doing this thing, Amazon is doing this thing, and that's why you are buying and you are emptying your credit card day by day. No offense. So, face detection, face recognition, image classification, speech recognition, and Google search queries, and even antivirus programs, anti-spams that you can like identify what is a spam and what is a ham in your inbox, genetics. So those are the fields that machine learning is coming forward, and those are the fields that machine learning is used currently. So I said like machine learning is a not a new thing, and it was evolved in the past. But why it hadn't been such a hype in the field? Why? Let's find out why. Uh, if you go for like 60s or the 70s, where machine learning got the first hints, these are the machines that we had in that time. So these are the machines or the storages that we had at that time. Huge machines that will fit on a room, and huge magnetic tapes that store few megabytes was the machines that we had. A very limited computation power that we had. But then people realized that to compute the machine learning algorithms that we had with some kind of complex matrix multiplications and metric operations, these huge machines are not enough. So we had to move on, and we had to move on without machine learning till the computation power comes to the world. Why the computation power is that much crucial? Why the computation power means a lot for the involvement of machine learning. So this watch this small video. So I'm pretty sure you're familiar with racing, and you're a huge fan. I'm a huge fan of racing. So the data, what is the what is the like connection between racers and data? If you can imagine, like how much of data is gathered during a Formula One race that generates terabytes of data during a race. It says like race teams combine to generate like 243 terabytes of data from their vehicles in 2014 US Grand Prix. It's a huge amount of data, a large amount of data. That means to produce that kind of data, we can't use the machines that we had in the past like this. We can't use those machines. We need a twist. So the cloud came. The cloud came into the industry uh, with extended data center infrastructure and high level scalability, and they had the built-in blocks, and most of the cloud was with open source. And you can see like you can share the code base within the cloud and reduce the management, reduce all the cost, electricity cost, cooling cost, and all. Cloud came to the industry and machine learning got its boom. So these are some popular cloud service providers that you have currently that involves with machine learning. Google is leading the market with Microsoft tie to tie with Azure. They are offering all set of machine learning tools. Recently, they released a machine learning Azure machine learning workbench that working on a standalone PC and can do all the items that machine learning involved as an IDE. That's a very fantastic tool that you should try. And Amazon Web Services also offering machine learning tools as well as IBM. IBM Watson is the brand name for the machine learning and cognitive services. When we go for the theoretical part in machine learning, we'll see what is the main two parts that we involve in machine learning. One is supervised learning, and the second one is unsupervised learning. In supervised learning, we have a set of labeled examples to learn from that is called as training data. What we're going to do is we're going to develop the model from the training data, and we use the model to make inferences about the new data. That is the magic behind supervised learning. When it comes to unsupervised learning, that is unlabeled data. We don't have labeled data as we had in supervised learning. In unsupervised learning, we have a set of unlabeled data. What we do is we look for the pattern or the structure in the data, or the pattern or the structure in the data, and we do predictions based on the patterns or the structure. So there's also like between approaches like semi-supervised learning, which is having labeled data as well as unlabeled data, and also active learning, that is having semi-supervised learning as well as like we ask for the users for the label. You can see like there are two parts as supervised and unsupervised. Classification and regression comes under supervised, while unsupervised goes with clustering. The theories, machine learning algorithms. Uh, these are some terms. I'm not going to explain all these terms in this small time because it might get you bored. For regression, you get simple linear regression that you find in your O levels like y equals mx plus c, and polynomial regression. And then we got the decision trees and random forest for supervised uh, machine learning algorithms. For classification, we get k-names, k nearest neighbors, trees, as well as naive bayes, and then SVM, support vector machines. So when it comes to unsupervised learning, for the continuous data, we get SVD, and then we have k-means or the PCA for clustering and those things. And for categorical data, we have FV growth and hidden Markov models or the hidden Markov chains that normally are very fundamental stuff in AI. Those are coming with machine learning algorithms. So if you have any question on these algorithms, I'm like super open to get you an idea, and just comment below and we'll have a chat on that. Right. Deep learning. I'm pretty sure you all want to know about deep learning because that is becoming the most whispered word in the industry right now. Deep learning is attached with neural networks, artificial neural networks. If you go for the neural networks is not a magic, is not a black box. Please get rid from the idea of a neural network is a magic or the black box. It's not a black box. I'll explain why. So neural networks is a mathematical combination or a set of mathematical equations. There's no magic behind it. We have an input layer that gets the data as inputs and a hidden layer, and we have the output layer that gives the output or do the prediction. As I said, it is involved with some kind of mathematics with activation functions and weight values. Those are the things comes under neural networks. Not going to explain these things because this might get bored if I explain all the magic or the maths behind neurons. Just search and you will find very good reads on neural networks and how the mathematics going behind them. This is not a magic. So in deep learning, what we do is, as you see in the previous one, we had only one hidden layer in this neural network, only one hidden layer. But when we go for deep learning, we have many hidden layers with that. The main advantage we getting with deep neural networks is there's no feature engineering that we need to do. That means we can get all the inputs. That means we'll say in an image we can get many pixel values and do the prediction using all the pixel values, and no overfitting comes with deep neural networks. Sometimes the overfitting might come, but in most of the cases there's no that kind of problem occurs with deep neural networks. Right. Data science. Data science is also involved in this topic because people are like talking data science was bit old and it is the essence of all these things like that. I would say data science is combination of all these parts. It is also known as data driven science because all the science is driven with the data. It is an interdisciplinary field that have scientific methods and processes and systems to extract knowledge or insights from data. It is having like three main parts. One is the computer science or the IT, and maths and the statistics, mathematics and the statistics, and then we have the domain business knowledge with that. All with the combination of those three parts, we get data science. I would say like data science teams will bring to the three things. One thing is statistics, and the second thing is programming, and the third thing will be product knowledge. That means if you want to become a good data scientist, you should be good in your statistics as well as in your programming and with product knowledge. Some people argue that data science is some kind of a sexiest term that replaces statistics. To some extent, yes, but data science is not statistics. It involves with computer science as well as with the product knowledge. A good data scientist should have the domain knowledge and the way he can get those data and how to involve these data in this computer interventions. That is the job role of a data scientist. So I guess you got a good idea what data science is and AI is and machine learning is. Just a rough idea, not going into the deep. So I'm pretty sure like the people who joined this live conversation want to know how to get involved or how to become a data scientist. How can I become a data scientist and how to become like how to go through these things. So for this thing, I'll say this. You need to have a good skill set in these areas. We'll say this one. First one, maths and statistics. You have to have a good idea on maths and statistics. Uh, Please go back for your maths workbooks and all and get some idea about statistics. That is the base of data science, AI, machine learning, and all these things. You have to good in those things. and you have to have a substantive expertise on scientific field. That means how the scientific motivation hypothesis is going to build, and what I'm going to experiment, and what are the models that I'm going to build. Those things are crucial part. Then the next thing is hacking skills. Hacking skills doesn't mean that you're going to hack a computer. That means what you're going to do is you're going to have like a good skill set in your computer science background. That means you have to be good in programming, as well as how to apply those kind of programming methods in real world applications. We'll say you are good in Python or R, then you might think like, okay, I can become a data scientist, so I know Python and R and I know my maths. But you need to know how to deploy those things in a server, how to deploy this thing in a real world application, how to serve this thing with a mobile application. Those things you need to know. So you need to have some kind of hacking skills. That means a good knowledge in computer science. And then with all these three aspects, a data scientist may occur. So get ready to become data scientists, because or AI experts or machine learning experts, because the industry needs a hell a lot of them currently for the industry, because industry is searching for data scientists and machine learning experts to make their clients happy. That means make very good applications. Okay, right. This is the crucial part. People talking about AI and people talking about a boom in AI or artificial intelligence. So, what will happen in the future? What will happen in the future? Do you think these kind of scenarios might happen? Do you think like Terminator or AI powered killing machines, killing beasts will occur in the future? So, that's a question that we have. There's an interesting debate going on. Recently, it got some boom. Mark Zuckerberg, well known for Facebook, and Elon Musk, well known for, we'll say, well known for many things, for Hyperloop, Tesla, and many things, and SpaceX. He's saying like the doom that we're getting with AI may have some problems, and we need to have proper regulations and rules through AI interventions. Mark is saying there's not such kind of a thing. Just AI is a tiny bit that a very good thing. I'm leaving this question for you, whether you think AI is good, or do we have to have good regulations. In my personal opinion, I'm with Musk. I'm saying you should have good set of rules and regulations to monitor and observe AI interventions. That's my thought. So all these things are based on data. We talk about like data science is based on data driven science. That means all these things based on like how the data is operating and the patterns of the data. When you deal with machine learning models, if you have built a machine learning model, you'll get to know like you are not getting like 100% accuracy. Your CEO may ask like you have built and you have spent a lot of time on these algorithms, and why not we are getting 100% accuracy? No, that's a myth. No machine learning algorithm can give you, or an AI algorithm can give you 100% accuracy with the output. That's a myth. If you're getting like 100% accuracy with your ML algorithm, most probably that's overfit. So if you're getting like 80% recognition rate or 80% accuracy, you have built a very good model. So if you torture the data, because we are talking with the data and we are like dealing with the data, if you torture the data, that's at that time you'll you'll get the opportunity and then your data will confess the magnificent facts. So torture the data and do the data what you know, do plot them and do the calculations with them, and they'll give you proper insights with that. So I'm moving for the questions. If you have any questions, you can move with the questions. So any questions that you having right now on these fields, on data or AI? I'm here for answering any questions because I didn't go through like deep facts with AI and all, because that might get you bored. So if you have any concerns about theoretical facts and all, we'll have a discussion later in my private inbox or something. So that would be better, not going in this kind of like hard technical talk. Sure. I got a question saying, can you explain a bit on RNN? That is for recurrent neural networks. So I guess for recurrent neural networks, that is hardly bound with deep learning and deep learning technologies. So it is like, how did I say? It is like getting the input of the neuron and doing like backward recurrent path and learning that neural again. So I guess having some kind of a written documentation or something like that would be better for RNN. We'll do that RNN thing. Right. Another question. There's a lot of resources on internet on machine learning. Any specific modules that you can follow, right? For that, I would say if you a beginner in machine learning and AI, there are many good courses, online courses that you can follow. One thing is Andrew Ning, the guy with machine learning. If you search for machine learning online courses in the internet, Andrew's course will come in the first. So that is one of the best courses that you can follow, Andrew's machine learning course. He's also recently released a course on deep learning. That is a very good course on deep learning, and that is a very good place that you can get started. As well as if you want to go with the programming parts, Data Camp is a good resource that you can enhance your Python or the R scripts, and that would be a best place to get started. And then another question, it says how much have been achieved in AI by Microsoft? Okay, a bit of a tricky question. In AI, Microsoft is working a lot on Cortana, as well as with other neural network patterns like deep neural networks. They have built their own deep neural network framework as TensorFlow with the Google. They have built their own thing called CNTK. So they are doing pretty much good experiments with that, and if you familiar with the ImageNet, they are pretty good with ImageNet classifications with CNTK. There's an achievement, and if you think of like sci-fi kind of behavior in Cortana, I bet that kind of behavior is not coming in the near future. That means near 2 3 years. That won't be here, because uh, currently Cortana is also acting as a general purpose chatbot, having the ability of natural language understanding, not natural language generating. Microsoft is currently researching on that kind of stuff. So that is the thing I can say about what they have achieved so far. And then another question, any tools to get started? That means for machine learning. Right. Would say you that it's better if you can start with R or Python. My personal favorite is Python because that is very much familiar for the programmers, and the things you have in Python is very simple. So, if you want to start up with some machine learning experiments, start with Python and start using some libraries like scikit-learn. You will get some good idea with that. And then, if you want to deploy your machine learning experiments, uh, one thing that you can use is Azure Machine Learning. Search on Azure Machine Learning, and you will get like a drag and drop interface that you can build machine learning models in few steps. I'm not telling that you can become a data scientist by just knowing Azure Machine Learning, but that is a good step for the programmers to go forward and move forward with building machine learning models. So Azure Machine Learning and Python, scikit-learn, those are some good things that you can go with. And Azure Machine Learning Workbench recently released, that is also a good tool. Search on that also. Right. I'm starting with machine learning. I just clear my concept about machine learning depends. Now I want to make my career. So where can I start? Right. That means you're going to start with machine learning and you're going to build up your career path in data science. The data career path in the career path in data science in Sri Lanka. So it's blooming right now. Many companies are looking for data scientists and data analysts, as well as some companies are looking for specific people who are able to build chatbots, as well as the people who are good with analytics and data visualization. So there's a very good path, that a wide path in Sri Lanka if you're good with machine learning and stuff. So don't like say like there's have only low opportunities. There are opportunities not only in Sri Lanka but also in nearby countries like Singapore. There are many opportunities. What you have to have is a good idea on data science as well as good in your computer science. Because I would say in the near future there would be many careers in Sri Lanka that focuses not only on data science as well as some kind of a computer science background plus data science. That means a data engineering role. So you have to good in your programming as well as with your maths. So there would be many opportunities on that. Right. Can you tell a few business ideas to start with machine learning background? Okay. I'm not sure whether I'm coming up with that kind of ideas right now, but if you think out of the box, I would say like there would be many new ideas that you can build upon machine learning and go for the clients. Clients will love them. So we'll discuss on those ideas and we'll have a chat and we'll see what we can do with machine learning for to build a startup or build a business. Right. What are the questions that we have? Any tools? So I answered for that question. Right. As in undergrad, what are the free tools I can utilize for my project? Right. Free tools. Python is obviously free, so you can use Python. And you can use Visual Studio for your IDE to develop Python as well as R. Visual Studio Community Edition is free and you can use that thing. If you're not going for Visual Studio, then go for R Studio or Visual Studio Code that is working in your Linux machine as well as your Mac. So those are some tools that you can use. All those are free. Most of the things are free. As in Azure Machine Learning also, there's a free workspace that you can use, but with few limitations than in the paid version. So many things that you coming with Python is free. R is also free. So those are the tools that you can use freely as undergrads for in your projects. Right. There's a question NLP tools which can be used for project, open source tools. Right. NLP for natural language processing, Python is very supportive. There's a library in Python called NLTK, Natural Language Toolkit. That is one of the best tools that you can use for NLT, natural language processing. And then there's Stanford NLP well as in Apache they have Open NLP. So those are some tools that you can use for natural language processing. Right. They have a team, they're going for a startup, so we want all from scratch. So need to know good resource that are available online. Right. For that, have a good idea that what machine learning can do or what AI can do and what AI couldn't do. So for that, have a good idea what are the abilities of machine learning and do a brainstorm session and you'll get with some crazy ideas. Do a POC and go for the client and you'll get a chance. So many are asking about online resources. Online resources. As I mentioned earlier, Andrew's machine learning course and Andrew's deep learning course is a huge hit. So you can follow those things. As well as in Microsoft, they have a data science professional program. So you can go with that. There are many resources in MVA, Microsoft Virtual Academy. All those are free. You can go with the data science part. In that you can get an idea about R as well as on Python and how you can use Azure virtual machines with machine learning stuff. So there are many resources in MVA too, Microsoft Virtual Academy. Just go for those sites. Right. What are the mistakes you made along with in the way in learning machine learning? One mistake that you are going to make is just stick in one language or one paradigm. That means like if you're good with Python, don't just stick into Python and just have an idea about R2 and other languages too. And if you very good in maths and very good in machine learning theories, get an idea about what are the modern computer paradigms like distributed computing, how to use GPUs in machine learning, and how to adopt cloud for machine learning paradigms. You need to know these things too. So don't make that mistake of being into one theoretical approach. There are many approaches, many practical workarounds that you can use in machine learning. Right, any online platform to train CNN. So there are many online platforms that you can use to train CNN. That means here, as I see, what you need is a computation power with a GPU. So what you can do is you can deploy a virtual machine with GPUs. Uh, Azure is providing as well as AWS is providing. Azure, I know about Azure, so they provide a Tesla K80. It is having like 4,000 plus GPUs in that Tesla single GPU. So you can make a VM on that and you can train your CNN on that machine. Right, it says they need a platform for image processing. For image processing, yeah, you need a CNN. Then go for a VM. I would say a VM with GPU capabilities. Then Azure for ML or AWS Watson Blue Mix. That is based on your opinion. That's your choice. That's your choice. Azure, AWS, or IBM. That's your choice. Go with what you feel good. So Andrew Ning's machine learning course is pinned in this post, so you can follow that course. So I guess like that is one of the best courses that we currently have on theoretical approach of machine learning. Right. Any thought of Kaggle? Yes, Kaggle is one of the best places. Sorry, I forgot that thing. Kaggle is one of the best places that you can practice machine learning and all these algorithms. Go for Kaggle, do the projects that have been Kaggle, and you can get a good opportunity to learn as well as to see how the other programmers are dealing with the problems. So Kaggle is one of the best places that you can practice machine learning. Right, your advice to undergrads who go with deep learning in research projects. Wonderful. If you are an undergrad who's going to do your research project on deep learning, that'll add a huge value for your career, to build your career. So go with deep learning. So there are many deep learning platforms or the frameworks currently. CNTK, TensorFlow is leading, and then Torch, Theano. Uh, so many deep learning paradigms coming in. So go with deep learning. Okay, seems we have got very good questions. Many are asking about opinions, whether like Azure is good or IBM is good or AWS is good. That's based on your choice. What feels you good, choose that thing, and be familiar with the paradigm or the platform, and you will get a good opportunity to search, and you'll get a good opportunity to experience all the resources that they are giving. One of the main advantages that you get with Azure is they have something called Cortana Intelligence Suite. If you search in Azure, you can find out that thing, Cortana Intelligence Suite, that is coming as an umbrella product with many products and frameworks that you can use for processing data, not only for machine learning and AI, as well as for cognitive computing, big data analysis, data warehousing. They are providing many products and services on that. So that is one advantage that you're getting with moving with Azure. So seems we have got very good questions, and hope you enjoyed the session. If you have few many any questions so far, or if you have any clarifications on AI, ML, or deep learning, uh, just ping me. Just find me on internet in Facebook or Twitter. Just visit my blog and see what I'm blogging, and we'll have a discussion. And I'm totally open, and it will be my pleasure to help you with the facts that have. Right. The last question I'm going to take is how the deployment of such build model in production. Deployment you can do as a web service. I'm not sure whether like he's asking about right in right. Not sure about the question, but he's asking how's the development of such build model. You can deploy on a web server as a REST API or a batch request API. There are many methods that you can host a machine learning experiment. Right. So, thank you very much for joining and hope you have a very good session and you have enjoyed what I have said on machine learning and what I have shared on machine learning, AI, and data science. If you have any question, you can just ping me on my Facebook as well as on my Twitter. Here you can find my Twitter ID, so you can ping me on Twitter. We'll have a discussion on these interesting fields in the near future. Hope you're going to build your career in machine learning and artificial intelligence or data science. That would be a great hit for you. Thank you very much, and thank you SEF, Sustainable Education Foundation, for giving me the opportunity to share the ideas. Thank you.